You spend weeks writing a 500-line SQL query. It has multiple joins, complex aggregations, and it delivers exactly what the stakeholder asked for. It runs perfectly on the first try. Delivering exactly what is asked without producing an error feels like mastery. You think you understand data infrastructure because your output is correct. In reality, you have only reached the baseline of competency. Relying on this exact behavior traps you at the entry level. It turns you into a SQL mechanic. You wait for support tickets, you fix one-off problems reactively, and you work in complete isolation. A data architect operates entirely differently. Stakeholders go to the architect when they don't even know what questions to ask yet, because the architect anticipates business needs before the request is ever made. Achieving the title of senior or staff engineer requires abandoning individual queries. You must shift how you interact with your organization's entire data infrastructure. This diagram maps data career progression. The top layer represents the get hired phase for entry-level data pullers. Here, you execute basic operations to answer literal questions. To reach a senior role, you move to phase 2, anticipating business needs and optimizing your code. The final boundary to cross is phase 3. Transitioning from advanced practitioner to staff engineer or architect means you stop writing standalone queries and start building enterprise-wide systems. To understand how to actually navigate this roadmap, we need to deconstruct the specific architectural upgrades required at each of these boundaries. True progression means scaling the impact of your code from generating a single spreadsheet to creating an automated organizational asset. Look at a typical entry-level script. It is a long, linear monolith executed from top to bottom. This monolithic structure is incredibly fragile. Critical logic is buried in subqueries. Hard-coded dates are hidden. A single unexpected null value in row 50,000 will crash the entire execution without warning. The advanced practitioner breaks this monolith apart using common table expressions, or CTEs. A CTE is a temporary named result set that you define and then reference within your main query. By fracturing the query into CTEs, you create isolated, debuggable layers. If the final output is wrong, you can test each distinct layer independently instead of dealing with a single massive failure. This modular layout allows engineers to pull those buried hard-coded values to the top of the file, creating a single, configuration-driven source of truth. You have taken a piece of cryptic, personal code and turned it into a documented team asset that anyone can safely modify. This comparison chart shows how an advanced practitioner handles data volume. Notice the distinction. Entry-level code works on small datasets, while advanced code handles millions of rows using explain plans. A query that executes flawlessly on 10,000 rows will frequently time out and fail silently when applied to 10 million rows in production. You stop guessing why a query is slow. Instead, you use explain commands to expose exactly how the database engine is executing your joins and filtering your data. Because you understand the underlying execution, you stop delivering simple raw numbers and start delivering clear insights and recommendations based on highly efficient data pulls. This proactive validation builds deep trust. You become the go-to person when leadership needs complex logic verified. You no longer ask if the script works. You ask if it will survive a 10-fold increase in data volume. Optimizing individual queries still keeps you focused on specific outputs. The next boundary requires shifting your focus toward the system itself. The primary enemy of an enterprise system is duplicated business logic. When analysts write varying case statements for an active user, definitions drift and dashboards contradict. The solution is the user-defined function, or UDF. It lets you write business logic once, saving it natively within the database. UDFs encapsulate that logic. If the company changes the definition of an active user, you update the single UDF, and every downstream dashboard updates automatically. You elevate yourself from optimizing your own code to instantly upgrading the code of everyone who queries the database. This second chart outlines the tools required for staff-level architecture. We look closely at how automation and resilience replace manual execution. Fragmented manual scripts require human babysitting. If an error occurs halfway through execution, the process stops, leaving partially updated tables that require manual intervention to clean up. You replace these with atomic stored procedures. These bundled multiple SQL operations into a single transactional pipeline. The execution either succeeds completely or it rolls back entirely. Stored procedures provide comprehensive error logging. They catch their own failures, record the issues, and trigger automated recovery steps without human input. By layering dynamic SQL inside these procedures, the pipeline adapts. Dynamic SQL allows the procedure to alter its own structure using parameters, handling varying scenarios instead of relying on rigid, hard-coded instructions. An architect builds pipelines that run, log, heal, and adapt themselves while the engineering team sleeps. Looking at the complete roadmap, the transition is clear. You start by pulling raw data on the left and evolve into designing scalable platforms on the right. But an automated platform requires strict oversight. The final responsibility of the architect is comprehensive governance. You replace inconsistent access with enforced row-level security. You implement strict audit logs and establish clear data lineage so every metric can be traced to its exact origin. Technical automation is ultimately meaningless without the organizational trust provided by strict governance. Writing an error-free query that delivers exactly what a stakeholder asked for is a great way to stay a junior analyst forever. To reach the highest levels of data engineering, you must become a force multiplier. You stop solving one problem at a time. Instead, you build the centralized functions and automated procedures that enable everyone around you to solve problems faster. The journey to data architect is not about learning every SQL function. It is a structural shift toward building systems that scale for years. Audit your current codebase, identify the monolithic linear scripts, and begin re-architecting your team's foundation today.